Hello everyone. In this video, we're going to talk about the three different types of programming errors. Specifically, we're going to talk about what are the different types and how do we tackle debugging each type, because our approach is a little bit different for each type. So go ahead and open up your virtual machine and navigate to your 121 folder and create a C++ file called errfun and code up an empty main function inside of it. We're going to write some code today that is intentionally buggy so we can learn how to track down those errors. Writing code that contains bugs is just part of the process. It is completely normal to write code that has bugs in it. Although bugs are undesirable, in order to hunt down and fix bugs, you have to develop skills. And in the beginning, it can be desirable to purposely introduce bugs in order to try and hone those skills. So that's what we're going to do today, and I encourage you to continue doing this in your practice. And even when helping others, for example, with compiler errors or other types of errors, if you can get as much exposure as you can to debugging, you're going to become a better debugger and you will spend less time debugging and more time writing good, fun, working code, which is essentially the goal. But do know that bugs are very common, they happen all the time, and there's no reason to get frustrated about having bug. It just means you need to solve another problem, which is good practice. So there are three main types of programming errors. The first one you've already been exposed to, and it is a compiler, aka syntax error. So you'll get this type of error when your code does not adhere to the syntax of C++. So take a moment and think of a few examples of compiler errors that you've probably already encountered because you've been writing quite a bit of code already in this class. So I'll put a few down here: missing a semicolon, or maybe misspelling, a variable name, etc. So let's go ahead and open up our errorsfun.cpp and introduce some compiler errors. So let's say I'm missing this opening curly brace. And I go to compile this, and I get an error. So first thing you'll want to do when debugging compiler errors is look at the line numbers. If you don't have line numbers turned on in gedit, you can do so under Preferences. We want to start with the first error. Don't start at the bottom down here. Start with the first error. So this one is on line number 9. So I'm going to identify line number 9. Okay. It says expected identifier before numeric constant. Okay. Expected identifier before numeric constant. So that one's not too informative, but if I keep reading down, let's see, error, name return values are no longer supported. Okay, that one might be a little tricky as well. But then this one, it says error, expected curly brace at end of input. Okay, well, that is pretty easy to figure out. So it says we've got this closing curly brace, we're missing an opening curly brace. Okay, great. So the moral of this debugging story is you always want to start at the top, but if the first one is not quite informative or maybe you don't know how to interpret it, you can go ahead and read on until maybe you find one that you do know how to interpret. Okay, let's say that I forget Let's do a cout statement. And let's say I forget to have this using namespace standard here. Okay, so line 6, here's line 6. Error cout was not declared in this scope. Okay, so it doesn't know what cout is. If it ever doesn't know what cout is, that's probably because you've forgotten this line. However, you could still compile this code without using namespace standard. You would just need to have std standard and the scope resolution operator, double colon, don't worry too much about it, here in front. Okay, now it's complaining and saying endl was not declared in this scope. Okay, well that's interesting. So now we know that endl is also part of the standard namespace. I could put this on here and compile it, and now it compiles and runs. Okay, so far so good. Let's do one more error here. Let's say, oh, we'll do 2 more. Let's remove a double quote and see what that error looks like. Okay, so line 26, we actually get a warning first and then we get an error. And it says missing terminating character, double quote. Awesome, that's pretty informative. And then let's say, we'll compile that again. Let's say instead of using the stream insertion operator, I accidentally use the stream extraction operator. Get this really, really, really long error. We always want to scroll up and find the first one. Okay, so it says no match for operator, and here's our operator. The types are ostream and constchar. And it's saying this operator here is not supported for these operand types. Constchar 12, this is like a string, and the ostream is actually the type that the cout variable or the cout identifier is. So at least it pointed us right here and said, I don't know if this is what you want here. That looks good. Now let's move on to our second type. We've got compiler errors. Now we have runtime error. So this is when your code compiles, but during execution it crashes. So a really common example of this would be division by 0. You know from your mathematical or algebraic background that any number divided by 0 is undefined. So if it's mathematically undefined, then it's also undefined in our C++ program. So this is a good way to take a look at a runtime error if you're dividing by 0. Another one is a stack overflow error due to an infinite loop. We'll see this perhaps when we get to the loop section of our units that we've been working on. Okay, so let's code up runtime error. Let's say we have a variable x and we'll assign it 5. And let's say x is assigned x divided by 0. So we'll compile this. And our compiler gives us a warning. Says there's a division by 0 here. Now, a warning won't prevent our code from being compiled. So we can still run it, but we should never ignore warnings, except in this one case when we're going to run it even though we have a warning, just so that we can see that we get a runtime error. So this is what a runtime error looks like. It'll usually say something like core dumped. So floating point exception, core dumped. So this is a runtime error. So it's not going to give you a line number to figure out where this happened. There are tools like GDB, new debugger, that you can use in order to find out exactly where your program crashed. But since we're not going to necessarily cover those tools in this class, the best way to figure out where and when this is happening, if you don't have a warning like this, is to use cout statements. I think cout statements are really great debugging tools. You can use them to localize the error. For example, let's bring back in our standard namespace. And let's say I'm not sure where the program's crashing, so I'm going to put a cout statement, perhaps every other line, something really simple. And then I'll compile and run this again. And I see hello there, and then the exception, and I don't see here. So I know that the program crashed somewhere before line 11. And I can use that to localize or kind of isolate where the problem is. So definitely make use of those cout statements. They are your friend. Use them to echo out important values. Use them to figure out where your code is executing, how far it gets before it crashes, etc. Now, the last error, number 3, is called a logic error. So a logic error occurs when your program compiles, it runs without crashing, but it gives an incorrect result. So a great example of this would be perhaps using 1 divided by 3 instead of 1.0 divided by 3.0 in our cone volume code. And we actually saw an example of that in a previous video where it would be a logic error if we're always getting 0 no matter what radius and height we enter in for the volume of our cone, because we're accidentally using integer division instead of the floating point division that we really want. There are lots of examples of logic errors. Anytime your computation is just slightly off for some reason, that could be a logic error. Or your code perhaps is not storing the values and the variables that you expect them to. It compiles and runs, doesn't crash, but you have a logic error. So same advice for debugging logic errors as runtime errors. Use cout statements liberally. They can really be helpful to try and identify what are the values of the variables that are related to the error, and you can really start to isolate from there. Some other tips and tricks that I have for debugging are listed here at the bottom of the programming errors notes. So a bug is an error in your program. It's really standard to have bugs in your code. Quite often, unfortunately, you'll probably start writing code that has fewer bugs as you gain more experience, but in the beginning, there will be a lot, and that is completely expected and completely okay. So the cout statements that I've been talking about, those are called diagnostic calls. They're really useful for sanity checks and just echoing out values. You can also use Google as a last resort, and I want to emphasize that Google should be used as a last, not a first resort. You're going to spend more time trying to find your problem online than you would if you just started working on the skills to figure out your problem on your own. Google should not be used in lieu of your own problem-solving skills. So only if you get really stuck trying to figure something out would I turn to Google, because it is a last resort and you really want to work on your debugging problem-solving skills.